In this video I will guide you on how to achieve the ECC requirement of subdomain 215 about web application security. First control is about cybersecurity requirements for external web applications must be defined, documented and approved. This means that you need to create a policy or set of guidelines for securing your organization's external web applications. This should include any specific requirements for the types of web applications that your organization uses, such as e-commerce platforms or customer portals. This policy should be reviewed and approved by the appropriate parties within your organization, and should be reviewed and updated regularly to ensure that it stays current with the latest security threats and best practices. Control 215.2. The cybersecurity requirements for external web applications must be implemented. This means that you need to put the security measures such as administrative controls, such as security policies and incident response plans and others based on your organization need outlined in your policy into practice. This could include configuring web application firewalls, WAFs, implementing multi-factor authentication, or setting up monitoring and logging systems to detect and respond to potential threats. Control 215.3. The cybersecurity requirements for external web applications must include at least the following. First point is 215.3.1 Use of Web Application Firewall, WAF. A WAF is a security solution that is placed in front of your web application to protect it from various types of attacks, such as SQL injection and cross-site scripting. By using a WAF, you can help prevent hackers from exploiting vulnerabilities in your web application and stealing sensitive information. When it comes to meeting the requirement of 215.3.1, which is to use a web application firewall, WAF, one approach is to deploy a WAF as a hardware appliance or software that sits in front of the web servers and monitors incoming traffic for malicious activity. The WAF can be configured to block known malicious traffic and can also be set up to alert security teams to suspicious activity. This can be done by using a rule-based approach, where specific rules are set up to detect and block known attacks, or by using a behavior-based approach, where the WAF learns the normal behavior of the web application and blocks anything that deviates from that normal behavior. There are many WAFs available on the market, both open source and commercial, that can be used to meet this requirement. Some examples include Mod Security, an open source WAF that can be used with Apache and Nginx web servers. Imperva Incapsula, a cloud-based WAF that can be used to protect web applications hosted in the cloud. F5 Big IP Application Security Manager, a hardware-based WAF that can be used to protect web applications hosted on premises. When it comes to implementing a WAF, it's important to note that it's not just a one-time setup, but rather an ongoing process that requires regular maintenance and monitoring. This includes regularly updating the WAF's rules set to protect against new threats, monitoring the WAF's logs for suspicious activity, and testing the WAF's configuration to ensure that it's configured properly and not blocking legitimate traffic. Additionally, it's important to have a clear incident response plan in place for when the WAF does detect malicious activity, so that the incident can be quickly and effectively dealt with. Control 215.3.2. Adoption of the multi-tier architecture principle. This means using a layered approach to securing your web application, with different security controls placed at different points in the application stack. This can include using firewalls, intrusion detection and prevention systems, and encryption, as well as implementing security measures within the web application itself. I would recommend implementing the principle of multi-tier architecture when it comes to protecting external web applications. This principle involves separating the different components of the web application into different layers, or tiers. One example of this approach would be to have a separate layer for the user interface, a separate layer for the application logic, and a separate layer for the data storage. By separating the different components of the web application in this way, it makes it more difficult for an attacker to gain access to sensitive data or disrupt the operation of the application. In terms of technology and tools, there are several options that can be used to implement a multi-tier architecture for web applications. One option is to use a web application firewall, WAF, which can help to protect the web application by blocking malicious traffic and monitoring for suspicious activity. Additionally, you can use a web application security scanner to identify vulnerabilities in your web application and help you to remediate them. Another option is to use a web application framework that includes built-in security features, such as the OWASP Top 10 or the SANS Top 25. This will help you to identify and prioritize the most critical security issues for your web application. It's also important to have a comprehensive security policy in place for users of the web application and make sure that all employees are aware of these policies and procedures and are following them. This can be done through regular training and awareness programs. It's also important to have a clear chain of custody for these applications and who is responsible for creating, maintaining, and securing these web applications, and this can be done by implementing a change management process. To meet the requirements of 2.15.3.2, it's important to document all of these steps, so that you have a clear understanding of your web application security architecture, and can demonstrate to the NCA that you have implemented appropriate security measures to protect your web application against cyber risks. Control 2.15.3.3 Use of secure protocols, e.g., HTTPS. HTTPS is a secure version of the HTTP protocol that is used to transfer data over the Internet. By using HTTPS, you can help ensure that data transmitted to and from your web application is encrypted and protected from eavesdropping and tampering. One example of a technology that can be used to meet the requirement of 2.15.3.3, use of secure protocols, is a web application firewall, WAF. A WAF is a security solution that sits in front of web applications and monitors incoming and outgoing traffic, looking for any malicious activity or attempts to exploit vulnerabilities. Many WAFs can be configured to block traffic that does not use HTTPS, which is a secure protocol for transmitting data over the Internet. This can help to ensure that all traffic to and from the web application is encrypted and protected from eavesdropping or tampering. Other technologies that can be used to meet this requirement include SSL, TLS certificates, which can be used to encrypt traffic between the user's browser and the web server, and secure socket layer, SSL, termination proxies, which can be used to terminate SSL connections and inspect the traffic before forwarding it to the web application. Additionally, having a robust incident response plan and a well-trained incident response team in place can also help to quickly detect and respond to any incidents that occur. Control 2.15.3.4 Clarification of the secure usage policy for users. This means making sure that users of your web application understand how to use it securely, and what their responsibilities are when it comes to protecting sensitive data. This could include providing training, or creating a set of guidelines that outline what users should and should not do when using the web application. Control 2.15.3.4 is about clarifying the secure usage policy for users. This is an important aspect of web application security, as it helps to ensure that users understand how to securely use the web application and are aware of any potential risks. An example use case to meet this requirement would be to create a user training program that includes a module on web application security. This module should cover topics such as how to identify and report suspicious activity, how to protect personal information, and how to safely use the web application. The training program should also include a test at the end to ensure that users have understood the material. In terms of technology and tools, one option for delivering the training program is to use a learning management system, LMS, such as Blackboard, Canvas, or Moodle. These systems can be used to create online training modules and deliver them to users, as well as track their progress and test results. Additionally, using a tool such as a web application firewall, WAF, can be helpful in protecting the web application from common attacks, such as SQL injection, cross-site scripting, XSS, and cross-site request forgery, CSRF. Other tools that can be used include web application security scanners, which can automatically scan web applications for vulnerabilities and provide actionable remediation advice. In terms of documentation, you can create a user policy manual that includes the secure usage policy along with the procedures and guidelines that users should follow while using the web application. This manual should be made available to all users and should be reviewed and updated regularly. Control 2.15.3.5 Multi-factor authentication for users' access. This means using more than one method of authentication to confirm a user's identity. This could include something the user knows, e.g. password, something the user has, e.g. a security token, or something the user is, e.g. biometric data. By using multi-factor authentication, you can help ensure that only authorized users are. In order to meet the requirement of 2.15.3.5, which is to use multi-factor authentication for user access to external web applications, organizations can implement a variety of tools and technologies. One example of a technology that can be used to implement multi-factor authentication is a hardware or software token-based solution. These solutions typically work by requiring users to enter a one-time code generated by the token in addition to their username and password. This helps to ensure that even if a user's username and password are compromised, an attacker would still need to have possession of the physical token in order to gain access to the web application. Another example of a technology that can be used to implement multi-factor authentication is a biometric-based solution. This can include solutions such as fingerprint scanners, facial recognition, or even voice recognition. These types of solutions require users to provide a biometric input in addition to their username and password, which can help to ensure that only authorized users are able to access the web application. In addition to these types of technologies, organizations can also use various tools to manage the implementation and ongoing maintenance of multi-factor authentication. These can include identity and access management, IAM, software solutions, which can help to automate the process of managing user access and permissions, as well as security information and event management, SIEM, solutions which can help to monitor and analyze log data from various sources to identify any suspicious activity. Overall, implementing multi-factor authentication for external web applications is an important step in ensuring the security of the organization's web applications. By requiring users to provide multiple forms of authentication, such as something they know, something they have, and something they are, it makes it much more difficult for unauthorized users to gain access, which can help to protect the organization's data and systems from cyber threats. Another important aspect of securing web applications is to regular security testing of web applications, such as penetration testing, vulnerability scanning, and web application security assessments. These tests are designed to identify and exploit vulnerabilities in web applications, such as SQL injection, cross-site scripting, XSS, and other common web application vulnerabilities. This can help organizations to identify and remediate vulnerabilities before they can be exploited by attackers. One example of a use case for this control would be a financial institution that has a web-based application for managing customer accounts. The institution would want to conduct regular penetration testing of the application to identify any vulnerabilities that could be exploited by an attacker to gain unauthorized access to customer information. To meet this requirement, the institution would use tools such as web application scanners, which can automatically identify and report on vulnerabilities in web applications. These tools can also provide recommendations for remediation, such as patching or modifying the application's code. Additionally, the institution could use manual penetration testing techniques, such as trying to exploit vulnerabilities manually to verify that they are present and can be exploited. It's also important to have a comprehensive web application security plan in place that outlines the procedures for identifying, reporting, and remediation of vulnerabilities. This plan should include guidelines for regular testing, including frequency, scope, and types of tests, as well as procedures for reporting and addressing vulnerabilities. It's important to note that web application security is an ongoing process and not just a one-time event. In addition to implementing the controls outlined in the ECC for subdomain 215, organizations should also regularly perform vulnerability assessments, penetration testing, and security audits on their web applications. This will help to identify any potential vulnerabilities and weaknesses in the web application, and allow the organization to take action to remediate them before they can be exploited by attackers. It's also important to keep the web application software and any underlying infrastructure up to date with the latest security patches and updates. Additionally, it's important to have incident response plans in place that specifically address web application security incidents, and to ensure that all employees are aware of and trained in web application security best practices, including how to identify and report suspicious activity. It's also important to use a web application firewall to protect against known web-based attacks, such as SQL injection and cross-site scripting. Finally, it's important to monitor web application logs for signs of suspicious activity, such as failed login attempts, and to have a plan in place for responding to potential web application security incidents.